The Internet. The Internet can send and show an extensive range of information, such as applications of the World Wide Web, email, and peer-to-peer networks. Today, the Internet has extensive connections where it resembles the map shown below. However, as large as it is, the Internet is scalable. This means it is measurable in size, but it can grow to meet new demands. In the case of the Internet, it uses the Standard Internet Protocol Suite, TCP/IP, to link several billion devices worldwide. We will discuss this more soon, but for now, TCP is the Transmission Control Protocol. It essentially establishes the connection between two hosts. IP is the Internet Protocol. It establishes the Internet by packaging and delivering data from one host to another once the TCP has been connected. Let's explain this terminology a little further. The Internet uses communication protocols. Protocols are rules or procedures put in place to govern a system or affair. All devices connected on a network use the same communication protocols. For example, diplomatic protocol or etiquette governs how diplomats should behave. Digital protocol determines how digital devices should behave. Data that is sent and received from one computer to another on a network does not travel instantaneously. It takes time for the data to travel, whether it is through an Ethernet cable or across Wi-Fi. The rate at which data is downloaded or uploaded to a network is called bandwidth. It is measured in bits per second, kilobits per second, or megabits per second. Bandwidth speeds vary across the globe. You probably can stream a movie in your house without any issues. If you've ever traveled somewhere else, have you noticed that the movie lagged or buffered more than what you were used to? That is because the bandwidth at your location may vary from the bandwidth at your house. As of 2021, the current global average is a download speed of 105 megabits per second. In the US, the average is 195 megabits per second, and Singapore leads the world with 250 megabits per second. You may also notice a slowdown in your internet speed when there are multiple devices connected in your home. This occurs because the bandwidth is being shared. As more devices connect, each one gets less bandwidth. Bandwidth is the rate at which data travels, but the actual time it takes a piece of data to reach its destination is called latency. It is typically measured in milliseconds, which are thousandths of a second. It is difficult to fathom latency and that delays exist when data is transferred across the Internet. The bandwidth also impacts uploading and downloading speeds. The upload speed is the rate at which data is transferred from a user's computer to the Internet. The download speed is the rate at which data is transferred from the Internet to a user's computer. Most Internet companies have default settings in their services that allow for a higher download speed versus upload speed. Why? Well, most users will download more music, movies, files, etc. rather than upload. If they can provide a faster download speed in exchange for a slower upload speed, it's a bigger win for their users. Even if some computers on the Internet fail, the system will not. The Internet backbone, consisting of many routers, provides multiple pathways for information and data to travel. But major disasters to critical systems can cause major interruptions or slowdowns. Although the Internet core is reliable, individual devices that are connected may experience failures of connection because they only connect to a single point. An example of this is when the power goes down in your neighborhood. Your home devices may not have an internet connection because your local internet service provider lost electricity. However, the Internet is still running and working at a global level. Redundancy is the inclusion of extra components that can be used to protect against the failure of a system if some of the components fail. The Internet's design to have multiple pathways for data is one example of redundancy. Physical redundancy is when there are extra devices and pathways between them for sending data. Examples of this are backups made to hard drives, saving copies of a document in multiple locations, such as flash drives, etc. Even redundant power systems exist. They allow for other power sources to kick in and take over when the main power source fails. As a result, towns and cities don't lose power for an extensive amount of time. The Internet's ability to continue to operate without interruption when one or more of its components fail is called fault tolerance. There are many layers involved in routing and transmitting data in order to maintain operations, such as reliable protocols that notify the sender whether the data being sent is successful, and multiple pathways between parts of the system that allow for rerouting when one pathway fails. The diagram shown below is a model of the Internet. Notice that there are multiple paths that data can take to travel between any 2 points, which creates the fault-tolerant design. For example, if points B and L are computers and they're trying to communicate, there are multiple paths to get from B to L. A few of the possible paths are listed to the right. We can go B, E, G, K, L, or B, E, D, H, K, L, etc. Practice questions.